area networks or WAN, wide area network. So the name is also suggesting that it will be a very large area. It will be a country. It can be continent, or it can even, the network can even go up to multiple continents. Multiple continents. So wide area network is the biggest one. Okay. This is the picture of a continent. It is Australia. So the WAN, it may serve as a private organization. For example, we call it as enterprise WAN. It can also be some commercial service. For example, the transit network, in-between network. Let us take an example of a wired WANs. There are proper wire being laid. So company, for example, some X company, it has some branch offices in different cities. We are talking about Australia, so it can be Perth, Melbourne and Brisbane. These are big cities and they are connected through wired WANs. Now each of these offices, they will have computers, and these computers will be called as hosts. H-O-S-T-S, host. They can do, they can have programs, running some application, connecting. So all these are called as host. Other part of this network, a WAN network, we call it as a communication subnet. These dotted lines you see, a dotted shape, it is called as a communication subnet, or we can just call it as a subnet. Now you know what is subnet and host? So this subnet has the whole responsibility of sending the data messages from different host to host. So this subnet or the communication subnet has two distinct components or parts. These are the lines, which are the transmission lines. How we are going to send the data to transmission lines. And how to send data to a particular exact intended computer or computing device. For that, we have switching elements. So we have transmission lines and switching elements. The transmission lines are basically sending the data, that is moving the bits between the machines, between the host, between the different components here in the network. And these transmission lines can be a copper wire, can use coaxial cable, optical fiber is the best, and the radio links if the wireless is adopted. And often these organizations, they are using the different telecommunication company like the Verizon, like the Geos, like the China Mobile. The switching element or switches, this is not the switch I am talking about here, this is not that switch, okay? These are switching element, we call them as switches. And these are specialized networking hardware devices that would connect two or more connection lines, because there are multiple lines coming. How to connect them? So for that, we have routers. We'll talk about that router. So when the data is coming on an incoming line, who is going to decide an outgoing line, or who is deciding where to forward them? Switching element. The switching element task is this. So here we have the router. So these switching element here in WAN, we call them as router. So in most of the WANs, wide area network, the network will contain not one, but many transmission lines, and each connecting pair of routers. So the routers will be connecting these multiple transmission lines. And if two routers, they don't have, they don't share a common transmission line, what do? They will use, or they will transmit it using another router or some transit router or in-between router. So two routers that do not share a transmission line, they do it using the other routers. Why other routers? This is how I'm trying to show how does it go. Okay, there may be many paths. There will not be one path. There will be multiple paths between two routers. How you have to send the data. Now the data can take any of the route, any of the path. So who is going to decide that? Which path has to be taken? The packets are not that intelligent. The devices have to be intelligent. The algorithm have to be made. The algorithms are there. So there are many paths, and network uses this routing algorithm to decide which path has to be used. As I am suggesting, in WAN or any kind of transmission line networking, there are routing algorithms being used because you have to send the data to proper place. So network will use the routing algorithm, and the router will use what? When it gets the data, it will use the forwarding algorithm that to decide where to send the packet next. It can go to X router, it can go to Y router. So X or Y, where it has to send, the router will decide that using the forwarding algorithm. Let me give you a very brief overview of this network routing. We will be talking about Dijkstra and Bellman 4, etc. These are the routing algorithm being used. Now in this wide area network, we have virtual private networks and SD-WANs. What are these? So this picture you see is a WAN using a virtual private network. Now we don't have, say a company don't have a physical dedicated link. We don't have. How to then create a wide area network? So here VPN can be used. Virtual private network, because first of all it is providing a virtualization. You will feel that you have a network, but that will be virtual. Basically you are using some other underlying backbone of some other company or some other network. That is, you are using the resources in a flexible way. That is, you are using internet connectivity for example. So with a VPN, because the internet connectivity may vary in different links, the performance will vary. You are not aware because it is not your network. If you are using virtual private network, it totally depends on what kind of internet connectivity in between we have. And this network itself, which I am talking about, this can be operated by even a single organization. It can be even operated by a commercial internet service provider or an ISP. Okay. Now I'll show you a picture here, and this shows a proper structure arrangement where it connects the WAN sites to each other. Also, it is connected to the rest of the internet. So we have a WAN. It is connected together, and it is also connected to the internet. Whenever we are talking about a satellite system, because we have to take all the arrangements into account, wired, wireless, satellite. So here we are using WAN wireless technologies. So each computer on the ground will have an antenna, and it will exchange data through get and send data via satellite. The most easiest to understand example of wide area network is this cellular telephone network. So this cellular telephone network, we are using say Verizon or say China Mobile or Jio. We are actually using the cellular telephone network. And this is also a WAN, wide area network, and it is using a wireless technology. So we have gone through various generations, and every generation has increased the speed, increased the throughput, increased the bandwidth. The first generation was only analog, there is no digital, and only you can call, voice, no digital. The second generation was digital, but for voice only. Okay. That is, you can only call. But the third generation is digital, and you can use this for voice and data both. Fourth generation is purely digital, even for voice. The first, second, third, the voice was not digital. The fourth, the voice is also digital. But when we come to the fifth generation, there is only digital. Voice on the speeds are tremendous. GB, you will talk about GBs here. Previously, in the first generation, we will talk about kbps. So in this wide area network, if we take an example of a cellular network, each cellular base station, it covers a very large area than the wireless LAN. Wireless LAN cannot compete here. So this base station are connected to each other. This is just one antenna I am showing. There are multiple base stations. They are connected through, usually wired to each other. And the data rates of the cellular network are much smaller than the wireless LAN. Wireless LAN can go up to 7, 8 Gbps and even more. But more recently, what the organization are doing, because they have distributed settlements and they need to connect sites. So they are deploying the software defined WANs, SD-WANs. Wide area network that are software defined, and they are using various different technologies. They are trying to connect this disjoint side. For example, one network with technology 1, one network with technology 2, they are combining it. How they are combining? They have some service level agreement, that is SLA, across this network. So this is now a popular thing in the wide area network. The SD-WANs, these are one of the example of SDN, that is the software defined network. And this SD-WAN, software defined WANs, this is a technology that controls the network. And how does it control a network? It will use some programmable switches. They have some control logic inside this, and they will have a separate software program.